Thanks, Bob. I first met Nancy Mead about 5.5 years ago. I was attending a software conference in Pittsburgh, and of course, Nancy was based at SEI and Carnegie Mellon. And actually, we participated in a panel session together talking about software professionalism. And it was a session that was lots of fun, very interesting. And we're still kind of shaking our heads about, what's going on in the world of software engineering. But, we learned some things. But when the opportunity came to bring Nancy in to do a talk, since she's a IEEE distinguished lecturer, we said, we'll invite her to come and do a presentation for us. She says, I can talk about some of the things that we're working on now in the area of threat modeling research. And so Nancy is a fellow of the Software Engineering Institute. She's an adjunct professor at Carnegie Mellon, and she's interested in security requirements engineering, software assurance curricula. Before she went to the SEI, she worked a number of years for IBM Federal Systems. So, she and I have a lot in common because I, worked for Bell Labs for a long time. And, hey, developing large real-time systems is really complicated. So Nancy has more than 150 publications and invited presentations, and she's a Life Fellow of IEEE, distinguished member of ACM. And we're going to have her come and talk about threat modeling research and machine learning. So Nancy, if you can share your screen.
Great. Before I share my screen, I think it looks like a great group. A couple of caveats. Once I start to do the screen sharing and switch to my slides, I will really not be able to see very much of the meeting. So I'm probably going to go back and forth between the slides and an opportunity to talk at various points and get some feedback. The other thing that I have to point out is I've managed to put all my telephones in another room, so that won't be a problem. However, my dog insisted that he had to be here in the room with me. So if there's a chorus of barking, you'll see me leave the video for a moment, move the dog elsewhere, and then return. I know that all of us have been on a lot of Zoom calls, so this is probably not the first time we've run into these little situations of dogs, kids, whatever in the background. It kind of makes it more interesting in my view. So with that, I will go into the screen share and switch over to the slides. Great. So I can still see a few of you. Dennis, you see the slides okay?
They look great.
Perfect. Perfect. So this talk reflects on about 6 years of research, starting out with threat modeling and then moving into the implications for machine learning, which has become a really exciting area in the last couple of years. We've kind of been, like everything else, the virus has sort of put things on hold. I had intended to spend some time with collaborators in the UK and Ireland to try to push the research a little bit further and maybe get some students involved. But just as we were planning that, everything came to a halt, and Zoom meetings don't quite cut it when it comes to trying to advance things in that particular way. When you don't really know the people and you're just kind of trying to figure out what to do. Plus the students are barely keeping up with what's going on in their degree programs. So that has been somewhat of a challenge. But having said that, I'll be reflecting on our earlier research in threat modeling looking very specifically at cybersecurity and software threats early in the life cycle. So we'll be looking at that kind of analysis. We won't be looking at other kinds of threats that are not cybersecurity threats, and we won't be looking at responding to threats that have actually occurred at some later point during operations. So with that as background, let me see how I can, here we go. Advancing the slides is a little bit of a challenge. So first I'll talk about various definitions of threat modeling, and I'm sure this is still a dynamic topic, but if you don't have a definition, then you don't really have a context for what it is you're trying to do. Then I'll talk about the research that we did at the SEI that was in about the 2015-16 timeframe, a hybrid method that we developed based on that research and some experiments that we did with that. We then had a student project that was initially looking at threat modeling and machine learning. And then finally, I'll spend a little bit of time talking about where we want to go with that and some more recent activities, both on the research end and on the education end that might be of interest to you. So, as promised, what's threat modeling? We looked at 3 definitions. The first was, now I can see this screen share isn't working the way I want it to. I'm going to minimize you guys for the moment. There we go. I'm sorry because now I can't see anybody, but at least you can see the slides. And by the way, Dennis has the slides. They'll be available for distribution. You can always contact me. I've got the slides too, along with a whole bunch of background material. So the first definition was the one that we used in our research, threat modeling method, which we refer to later on as the TMM, an approach for creating an abstraction or a model of a software system, trying to identify attackers' ability and goals, using that model to generate and catalog possible threats that the system must mitigate. A second definition was one that was developed by Ford Motor Company working with Microsoft. They had kind of an interesting situation where one of their staff members had gone to work for Microsoft and then came back as a consultant to help them with threat modeling. And at that time, I was collaborating with both a colleague at Ford and some colleagues at University of Detroit Mercy. So we had several meetings to try to understand exactly what Ford was doing with Microsoft to support their threat modeling activity, which was really interesting in and of itself. But that's a whole separate talk. And we did write several papers on that collaboration. So there, because they're working with Microsoft and trying to use tools, they say threat modeling is both a methodology and a tool used to identify and classify vulnerabilities that could result in adverse business impact. Note the emphasis on business impact. So their big concerns were competitors trying to hack into their systems, safety, obviously, and loss of reputation, those kinds of things. So they prioritized their risks and decided which ones would actually be tackled for each project that came up, recognizing, as many companies do, that they could not address every single risk. So they were going to pick the ones that were the heavy hitters as far as they were concerned. So that was Ford. And then the most, well, I should say the one that uses the least words, threat modeling is a repeatable process to find and address all threats to your product. So there they had a product view, which fits very well with what they do. And in part, this work came out of the Microsoft push. We all remember the famous Bill Gates letter that started to address cybersecurity. And some of the work that we'll look at is the work that Microsoft did. So 3 different definitions of threat modeling. You notice that in none of these cases did we attempt to define threats. We had some very interesting conversations in-house about what a threat really was. A lot of discussion about that. Is the threat the person who's trying to do something? Is it the activity? Very, very much, at least at the time that we discussed it, an open question. So we decided that we would not go down that rat hole, but we would continue with the work that we were doing, which is what I'll be talking about next. But first, I'm going to back out of here and maybe. Okay, and try to ask a question, even though I can't see everybody. And so my question is, and feel free to unmute your mics to answer, is, are any of you folks actively doing this type of threat modeling or threat modeling research? I don't hear anything. Okay.
No.
Dennis, did you speak up?
I said, no, I'm not involved in anything like that right now.
Okay. And I know there are some folks here that I have no doubt met on earlier occasions. And we will just press on then. I can see there from looking at it, at the group, that there are a lot of very experienced folks here. So hopefully we'll have some interesting discussion.
I deal with the aftermath of the threats. In other words, something happened and then they found the person who did whatever it is that they're claiming they did, and then they're arrested. So I deal with the aftermath.
Right.
From the criminal defense side.
Luckily for me, I didn't get those phone calls in the middle of the night saying that there had been some kind of a hack. I didn't get the 3 a.m. phone calls, and unlike some of our leadership, I did not get unrequested pieces delivered to my door in order to let me know that some people knew where I lived, which was pretty scary in and of itself.
Hey.
Yes, it is. It is. But okay, cool.
Great. Okay, we'll carry on. So who uses it? Obviously, vendors like Microsoft, they use a tool called Stride and make it freely available. It's been around for a long time. Most people who do threat modeling are very familiar with it and will be talking about it. So certainly vendors that are developing products, government organizations such as the DoD, where it's mandated, and of course, not to be so US-centric, there are plenty of other government organizations that have similar concerns. I've done some collaboration with folks in the UK, and certainly in the European Union, it's huge. And of course, in Asia as well. So very popular topic. A lot of folks in the US government use NIST standards to help them with threat modeling, because very often they don't necessarily have the expertise on their projects to do a lot of heavy analysis themselves. And then commercial organizations, as we've seen, fortunately or unfortunately, some do a better job than others. That applies to all of the above. Various methods are being used, including STRIDE, risk analysis approaches, and then those would include things like octave, attack trees, misuse cases, and so on. Unfortunately, a lot of people try to do it in an ad hoc way, which doesn't always give the best results. So what we decided to do in the original project was to look at several of these methods. So this is just redundant with the last slide. Why would people try to do this? And this is the Microsoft viewpoint, very much of a product orientation. And I would also point out that at that point, they had a lot of software that had already been fielded. And so they were concerned not just with brand new development, but also with upgrades and trying to secure what was already out there. And that led them, in my view, down a slightly different path from somebody who was doing all new development and perhaps doing development of a different kind of product. So here was the research we did 5 years ago. It was, we thought it was good stuff, but it's certainly been superseded since then. What was, in my view, best about it is that we had a pretty large group that we were working with, and we were trying to do side-by-side comparisons, which we succeeded in to some extent. So we wanted to focus on early life cycle activities, such as requirements, engineering, architecture, design, independent of a specific life cycle model. So in principle, we did not want to care whether somebody was using waterfall, spiral, agile, or anything else. We were focused only on specific activities. We wanted to look at some competing threat modeling methods. And one of the things we noticed was that there was no concept of which one was the most efficient, which one identified the most threats, which one was best for a particular kind of application. People kind of just picked one. Maybe they were familiar with it. Maybe somebody on their team was familiar with it, but they didn't necessarily have a good reason or any empirical evidence to support those choices. So we had a one-year project. We studied 3 methods that I'm going to go into in a little bit more detail. And some of you, if you saw my talk on threat modeling between, say, 2017, 2018, nothing in this piece of it has changed because I'm still reporting on that same piece of research. STRIDE is the one that's used the most often. It, at least as of the time we started that research project. At that time, there were not a lot of threat modeling methods. Now there are at least a dozen that I know of, probably more. Some of them are actually commercial products. And so things have changed quite a bit, but we picked 3 that we thought were representative. And to show a little bit of bias, we also picked some where we had collaborators who would work with us. Because if you're just trying to do something in a vacuum, it's not so easy. So STRIDE, the most widely used in our view. Security cards was a method that was developed at University of Washington. And it's been used a lot in the classroom. And I found out afterwards during one of these talks, in fact, that it's now being used a lot in industry as well, which is kind of interesting. And then persona non grata, if you're familiar with the idea of a persona, this changes it around and said, okay, what if we have a persona who's actually an attacker? Again, I'll go into all of these in more detail, but we had collaborators both at University of Washington and in Idaho. And we had Jane Cleland Wang at DePaul University at the time. She subsequently joined Notre Dame. And she had been the lead developer of the persona non grata method, which at that time had been published somewhat in the literature, but not used that widely. And as I mentioned, in all of these cases, we didn't really have evidence to say, was one of these better than the other? Would one of them be better for a particular application? So we were kind of groping in the dark. Looking a little deeper at the stride approach, this was developed at Microsoft specifically as part of the security push. It's heavily documented. It has a tool to support it that has undergone a number of iterations. The tool is freely available. They have tutorials that are freely available, and you can find books on that include discussion of their threat modeling. When I was teaching this at the university, I found that they were very supportive of our using their material, their examples, whatever we found useful. So it was really a productive collaboration. Initially, it presumed that you had an analyst with some expertise who would produce a data flow diagram of the system. And the data flow diagram would go through a number of iterations to get more and more levels of detail. The data flow diagram was mapped to the threat categories that you see on the right. And of course, that's where the STRIDE acronym comes from. So on the left side of that little table, you see the threat. And then on the right side, the security property that you want to preserve or end up with by counteracting the threat. You could do this manually. Right now, the more recent tools actually presume that you don't have all that in-house expertise. And it's a little more of an approach that would allow lots of folks in an organization up through management to be able to use the tool and get some results. So it's relatively easy to implement, but possibly you could get different results based on the inputs that you provide. And when I used it with my students, they did pretty well with it, but again, came up with somewhat varying results. The nice part about it is that it's been used very heavily. What I found somewhat less helpful was that it presumed that you actually had a data flow diagram. And this was understandable because they were in part trying to address software that had already been fielded. It was perhaps not quite as useful if you were still very much in the early system definition phase. So here's a standard example that they provide, and this is actually pulled out of one of their applications. Here's how they represented data flow diagrams with rectangles or squares being used for external entities, circles for processes, parallel lines for data stores, and then data flow indicated with arrows. So a pretty straightforward approach. The nice part about it is the discussion of the fact that different threats affect each element. And you can see that in this version of the table that we looked at on the previous page. So it kind of makes it, to some extent, it makes it easy because it helps you know exactly what you need to consider once you have that data flow diagram. And here's the detail. I'm not going to go through this, but here's the detail of the elements of the STRIDE acronym, the property that you're trying to achieve, and then some methods that can be used. This is specific to Microsoft, and it's probably somewhat dated relative to what they might say right now. But it gives you an idea of what they were trying to do with the STRIDE method. And again, it is very widely used. The other things that we're seeing now is that there are some full life cycle methods that are actually commercial products that may or may not incorporate something like STRIDE, but might have something different instead for the threat modeling piece. So that was one method. That was the one that had been widely used. We kind of knew what it was. We had an idea of what experience people had had. The security cards was new to us. It was developed by some faculty and at the time grad students at University of Washington. And it's a support technique for brainstorming about threats. So there's actually a card deck. You can download the card deck, you can print the cards, and you can use it in a brainstorming meeting to identify threats. And each card has a front and a back. The front has a topic and a dimension where there are 3 or perhaps 4 dimensions that might be considered. And then on the back, this is kind of a cool thing. It gives some suggestions for kind of motivating the brainstorm, thinking about what kind of impunity might the adversary have. And in addition, to some extent, you might find examples or references on the backs of the cards. I think it was really neat for classroom use because it has kind of the idea of a game. We didn't find that our government clients were too interested in using something that looked like a game. It didn't seem quite serious enough to them. But we did see a lot of usage at university and at some companies. I think it depended on, to some extent, on the folks who were using it. So that was our second method. And then the third was persona non grata, which requires a little more discussion. Personas have been used for a long time in human-computer interaction design. And what they're used for is to try to imagine the users of your system by coming up with detailed descriptions of imaginary people who might be using it. So they're kind of a stand-in for an actual user and would give an idea of how a certain class of users might want to use a particular system. And there's one reference here. There are plenty of others as well. So here's an example of a persona, a retired accountant who wants to spend time with his grandchildren, likes reading papers, working in the garden. He likes technology, but only if it doesn't get in the way. And so the idea here is you say to yourself, well, what would this person be interested in? Would they be interested in help managing their retirement account? Are they interested in social networking? And by doing that, you get an idea of the use cases that might be associated with that person. Now, a persona non grata is basically using the idea of a persona to describe an attacker. This is somewhat structured because it looks specifically at motivations, goals, skills, and then ends with misuse cases. And once you have the misuse cases, you can then come up with the strategies to counteract them. So that's a persona non grata. We've got a real example of one that I'll talk about for a minute. Keeping in mind that this is a documented case study, and the analysis is being done after the fact. We all know that it's easier to analyze an incident after it happens than to predict it before. It's kind of interesting. It was a contractor working on SCADA systems, I think in Australia. And he applied for a job with the community, but was rejected. So he decided to use the control system to cause raw sewage to leak into local parks and make it look like a malfunction so that people would create a backlash against the contractor and the community. Well, I think he actually started to succeed, but got caught. So trying to put it into the format of a persona non grata, here are his skills, extensive knowledge. He no doubt managed to spirit away some computers and user IDs and passwords in order to do this after he was terminated. And here are the misuse cases. So it's a really interesting technique, but we all know that hindsight is 20/20. It may or may not be as effective if you're trying to predict. So using those three methods, STRIDE, security cards, and PNG, we put together a research proposal that was successful, but our research funding was for a year at a time. So we decided we would use it in the classroom with teams of students. And we were working at 3 universities in Washington, Idaho, and then at DePaul. We also had some professional threat modelers who were analyzing the same case studies. And when we did the training, we reversed things so that some students learned one method first and then the second one, and vice versa. We also developed 2 standard case studies. One was a drone swarm scenario, and the other was an aircraft maintenance scenario that were used in the entire project. Sometimes they were classroom exercises, sometimes they were homeworks. The students, we had a mix of senior level undergraduates and then master's students. Some of them were experienced, some of them didn't have much experience, some of them had cybersecurity experience, some of them not. So those were all things that we tried to control for. But these case studies are certainly available and make for a nice classroom exercise. So what did we find out? Well, we found out that there were a lot of differences. With STRIDE, there was a wide variety of results. With the security cards, they found most of the threat types that the professionals also found. But again, there was a lot of variability. Persona non grata, depending on your viewpoint, unfortunately found the fewest threat types, but the ones that it found were most consistent from one team to the next. And no single method led to teams reporting a majority of the valid threats. So the analysis that we did revealed at least that much about the three methods, but it wasn't really as satisfying as we had hoped. So there was no great aha moment where we could say, well, this method is clearly superior to the others. It just didn't come out that way. And you can imagine with 250 students working in small teams scattered across 3 universities, but each working on the same case study that was presented pretty consistently, we were hoping that we would get something that was a little more standardized than what we did. Once again, it was just 3 methods. Now there are a lot more out there, although they do have certain similarities and overlap. One of the things we wanted to do and didn't get around to in this particular piece of research was we wanted to find out if perhaps the professionals were wrong, and maybe the students found something that the professionals didn't see because they were doing things the same way every single time. We didn't have the opportunity to go back and do that analysis, in part because that research project ended, and then we turned to trying to apply our results with some customer work. And those of you who are involved in research or in industry know that doing a standalone research project is very different from working on a customer's project, because the customer obviously has their own project that they want to focus on. They're not as interested in being a guinea pig for a research team. Some threats led to types that were outside of the set identified for the experts. Maybe they were false positives that would never occur, or maybe they were just unusual. We did some further analysis with persona non grata that was later reported at the requirements engineering conference. We were able to do that with a grad student who was working with us at DePaul University. And so that was gratifying that we were able to actually do a little further work with the data. Those of you who have done this kind of research, it's considered human subject research. So unfortunately, we couldn't make the data itself publicly available for somebody else to take a look at. We had to kind of keep it among the team and then just report on the results of our analysis. In any case, we documented all of this and went on to say, well, since none of these 3 methods was exactly what we wanted, maybe we need to look at combining them in some fashion. Oops, I skipped a slide. So this is more on our overall results. Stride is typically used a little bit later when you have a system that looks like a data flow diagram. Security cards encourages thinking outside the box because it's a brainstorming technique, but the results vary. And PNG was a little more narrow, but provided consistent results. So we thought that perhaps by merging these approaches, we could improve on this combination. And we ended up mostly using security cards and PNG, but then we added in aspects of Stride as well. That led us to work the next year on a hybrid threat modeling method, we did this work. We defined the method, and then we collaborated with a group at University of Virginia and with a client to try to apply it. In the end, we didn't apply the method exactly the way we had developed it because the client's project was at a slightly different point in the life cycle. So we were able to apply some of the ideas, but we couldn't just take the method and apply it as we originally conceived of it. We initially said, okay, what are the desirable characteristics of a method? This is another place where we find that things tend to fall short. People don't think about what it is they want. They just invent something and then go off and run with it. So we at least tried to identify what we thought were the desirable characteristics, with this first group being objective. You know, they're obviously data that can be looked at. And then some of the second group are more subjective. In some of my studies, I found that if you're looking at methods, you might do a weighted average of some of these things. But since we were developing a method, we just kind of stated what our goals were. And there's a report on the hybrid threat modeling method that's available freely for download from the SEI website. That's in the references that you'll see at the end of the slide set. We presumed that it would be part of an overall process for identifying threats. And we presumed that before you went into the threat modeling, you would gather as much information as you could about the system that you were studying. And after the gray box at the other end, you might go on and do a formal risk assessment in order to decide which of these were important enough for you to address. So the key is the pink ones are the security cards, influence. Green is persona non grata. And blue is the influence of stride. Now, it's not as clean cut as it looks, but that was the idea. So the idea was that we would do some form of brainstorm with particular attention to malicious actors. So that's where the PNG starts to come in. Then we would get rid of the ones that we thought were less likely and itemize the use cases. Typical of a brainstorming activity is you end up with a lot of material that isn't useful. So we wanted to try to get it down to what would be useful along with the misuse cases, flesh out the threats using, again, certain elements of the security cards and elements of PNG. And at that point, something like stride could be very useful in identifying your mitigation strategies. And you could then go on and do your formal risk assessment. At the time I was working, I was actually the PI for this SQUARE method, which was a process for security requirements. I should say it is a process, and actually was incorporated into some follow-on research work on security requirements. So we kind of pulled the earlier steps and the later steps out of the SQUARE process. As I mentioned, we applied it on a real project, but we had to tailor the method. We couldn't just do what we wanted to do. And so we got feedback, but we couldn't really conclude as much as we would have liked from that single case study. We would have loved to have done more case studies, and I'd still like to do that, but the opportunity hasn't presented itself. A lot of the team members went on to work on other things. I went on to work on other things as well and then retired. So that kind of changed things, but I still think that this is a very fertile area for research, and I would be delighted to collaborate with somebody to push this along. The little bit of pushing that we did do takes us into the machine learning part of the talk. I had a student team. We had a master's in information technology and security. And I had a student group that was interested in machine learning. And we had another researcher who was also interested in threat modeling. And we were able to combine those two sets of interests with these students. I love working with students because I learned a lot about the way that they see things, and they have so much energy to bring to the task. It's really refreshing, and that's something that I'm missing right this instant. But this was in 2018, and this part of the slide set is actually the students' slides from their end of semester presentation. So they basically worked on it over summer and presented their results at the end. At that time, there wasn't too much being done in the area of threat modeling for machine learning. Since then, obviously, machine learning has become a hot topic, and so have threats to machine learning. So a lot more has happened since we did this little bit of research. And you've probably seen all of these even in newspapers these days, where there's discussion of how you can modify a small number of pixels so that the application doesn't recognize the actual object, but thinks it's something else. You see it where stop signs, images of stop signs for self-driving cars can be tampered with made to look like something other than a stop sign. And so there is a lot more attention to this than there was at that time. But at the time it was novel, and we were trying to get inputs that we could use. And it was a true statement. There were no security frameworks at that time. And there were only a few resources so that people could evaluate their machine learning models relative to attacks. What they decided to do was to build a website. And I should point out, it's important to note that the students actually defined the project to a large extent. We mentored them, but they were self-directed, and they assessed what they could realistically do in that time frame. And so they decided they would build a website that would allow a user to input a model and get feedback on adversarial examples. They used an existing library to test it out, the images being an input, and then the output being the adversarial examples that were generated by each method. Here are the details of what they did, and obviously some nice goals for it to be scalable, user-friendly, and to give comprehensive and reliable feedback. It's important to point out that each time you wanted feedback on a model, you had to start over again. So it was something where you input the model one time and you get results one time, but that was it. There was no concept of being able to modify the model and get an update. You had to put in the modified model and then get the update. The tool was made freely available, but again, being a student project, there was no support. And so I didn't get any indication of whether it was actually used in the field and what kinds of experience people had with it. And again, one of the things the students pointed out was they didn't have a big budget. They wanted it to be free. They used Amazon Web Services at the time, and they only supported Keras. They used a library that was freely available called Cleverhance. I don't know, I'm sure it's still out there and perhaps it's grown considerably since then. But it was a nice experiment, and it provided ideas for how one might proceed with threat modeling for machine learning. Clearly, it's a much bigger field than an exciting research field right now. So those were the three big things that we did. We learned that there was no single best method out of the three that we selected, and I suspect that may still be the case for all of the methods that are out there, whether or not they're commercial products, because I don't think the developers of the commercial products have done that side-by-side kind of comparison either. We developed a hybrid method and applied it to a small example and then to a medium-sized system that was documented in a report. And there's a podcast at the SEI. The only thing that's not really accessible is the database for the original initial research. And then finally, we completed the student project that was given to provide feedback to other research projects. So what's happening since then, and how can we look forward, which is really where I am right now. There are a couple of research ideas, and all of these suggest the need for collaborators, which is why I'm kind of stuck at the moment, even though when I give this talk, I do get some individual interest, but it's kind of more of a one-way thing where they are looking for information from me, but don't necessarily have time to participate in a research project. So I want to apply some other threat modeling methods to systems that will use machine learning to try to understand which ones are effective. And this is an opportunity for collaborating with both student teams and practitioners. I want to focus on some of our previous examples with a machine learning twist and see what happens, and develop some new examples that can be used in the process. That's one idea of pushing the idea of threat modeling from machine learning. The other idea was kind of opposite, and that was using machine learning to improve threat modeling. So can we use machine learning to improve resistance to attacks? One of my collaborators had an idea of using it in training to determine how well somebody had learned how to do threat modeling. So there were a lot of ideas around machine learning and threat modeling that were different from our original thought. The third activity that's going on is in the area of education. And I've mentioned this to a few folks. Working with a group in the UK that's developed a cyber body of knowledge. And I have a small project to identify case studies that can be used in the classroom and can also be mapped to their cybersecurity body of knowledge. Now, this is different from the NIST initiative. It's got more of a UK European focus than some of our work here in the US. And that's fine. There's plenty of room for additional work to be done in cybersecurity education. But the sales pitch is that right now, if somebody has an interesting cybersecurity case study that's A, suitable for classroom use, and B, can be shared with educators, meaning it has some kind of copyright statement to go with it, and it's allowed to be released under the proper conditions, I would love to have some of those. Now, the bad news is I don't know what kind of situation they were in over there, but it's a very short fuse kind of thing. And the work is to be completed by the end of April. So it's really just a couple of months project, which is why I tried to limit it to case studies that already exist and hopefully have been used, rather than trying to create case studies, which would be a much larger level of effort. So with that, there are a number of resources. The hybrid threat modeling method, which also discusses the earlier research, is available for download from the SEI. There's a blog entry that Forrest Scholl and I worked on together. The conference paper, further analyzing our data using crowdsourcing. And probably some of you who were at that conference may have seen this. And then finally, some of this worked its way into a certificate program at the SEI. These are some references that were used on the student project for machine learning. And again, this is not as current as it could be, but it's certainly still out there. And there are a number of other machine learning references as well. I really want to point out the last two because they're more recent. Gary McGraw has retired and formed his own little conglomerate. And they published a top 10 list, which is kind of interesting because Gary always used to say that he wasn't interested in the top N list, but in any case, top 10 lists of machine learning. So that is a very accessible article that's in IEEE Computer, and they have a website that you can access and also ask to be on their mailing list. Kind of at the other end of the spectrum, Mark Sherman at the SEI did a webinar on threats for machine learning that is much more in the line of the formal methods, mathematical analysis. So at the one end, we have something that's pretty readable about top 10 risks. And at the other end, we have something more mathematical, but perhaps a little bit deeper that was produced at the SEI. Unfortunately, it's no surprise, a lot of the work for some of these activities ends up being classified, but there's still quite a bit available out there. So with that, I'm gonna get out of this screen share, but first I wanna put my email here because I would love to hear from you. And perhaps we can define some work going forward.